Everybody. In this quick tutorial, I'm going to show you how to find a predicted energy use intensity value using Insight through Revit 2025. So what you see here on your screen right now is a basic model of a five-story office building. It's just a very simple rectangular building, not a lot of advanced architectural features. The families used here are very basic assembly types. For instance, I could pick this exterior wall. You can see it's a basic wall exterior stud with brick veneer. I can go into the structure here, and you can see there's not really any kind of indication of insulation values or anything related to thermal that's going to affect our energy calculations. And that's okay because we're going to resolve that through Insight itself. But this building has just all these very basic assembly types. The first thing you're going to want to do to run an energy analysis is in Insight. You'll see this under the analysis menu, the ribbon menu, you'll see energy optimization. And this first icon here, if you highlight that, that says location. The first thing you want to do is make sure that your building is located, that you establish a geolocation for it. And this becomes critical because based on your location, it's going to pull climate data. And so in this case, I have a project that is designed for Boston. And within this location and site menu here, you can either through this mapping surface option, or you can go to a default city list. You're going to want to pick the most representative location for your project. In my case here, Boston, Massachusetts, the site I have in mind is specifically in Fenway near Back Bay. And so of the different weather stations where I can pull data, I think I want this one that's highlighted right now for Boston. So I'm going to go ahead and pick that. And that's our first step. The second thing you're going to want to do is go to this icon that I'm highlighting here, system analysis. If you wanted to look at a system analysis, you could look at this. You can see here it performs an energy systems analysis and generates a report where you can get a whole building simulation and analysis. Here, if you were so inclined, you could look at um, creating system, creating a system zone for your project for analytical spaces, and you can also delete previous iterations. So just wanted to demystify this menu set right here. But our very next step, we're going on to go to the right to energy settings. So if you select this, you can see here in the energy settings menu, um, as use building elements, you can see just some very basic features that you could pick from. And what I'm going to do though is actually draw your attention to the advanced option down here. Uh, at a conceptual or schematic level, you might want to adjust some of this, understand where your ground plane is located, depending on your model and the way it's configured. Also, project phasing, very important, depending on the phase of your project and what you're wanting to assess. So do a quick check over these basic options. But when you go to the advanced options menu here, you're going to see a list of options that are going to actually have a very big impact on the energy use intensity, the energy performance of your project. Notice this first one here. This is shaded out. This information is active when instead of a model that you can see, a Revit model where I have some basic assembly types and it represents a piece of architecture. It has enough information in it that we can start to define what some of the assembly types are, the thermal enclosure, et cetera, et cetera. But maybe we're at a very high level. We're at a conceptual design phase, and all we have is a basic massing. And we don't even have proportion of opaque versus window areas established, for instance, with our walls. You could use this detailed model menu here to start to define that. So I could have a conceptual mass, establish some floor planes, and then I could come into here and I could say, okay, we have a 40% window to wall ratio, or maybe we have 30 or 60, whatever it may be, if I have shading. So this is for that conceptual level. We're at more of a schematic level now. And so if I go down here into the other menu options, you can see the export complexity, and you can establish how detailed of information that it's going to pull from your model. I'm going to go with the more advanced complex with mullions and shading surfaces at this level of development that I have exhibited here. You can see the building envelope, use functional parameter. You can pick this and identify exterior elements if you so choose. This will have a pretty consequential impact. The building service, right now it's got a variable air volume single duct system. I can make that a dual duct. I can make that terminal reheat. I could make it a fan coil system. I could make it a CAV system. You could go with, you can see here for yourself, just a number of different system types that you can choose from and pick the one that's most appropriate for your project. Building infiltration class. Infiltration can have a major impact on the heat exchange through your building envelope, so you can define this. I'm going to cite it as a medium class, go middle of the road here. This is an office building, and building type office, that's appropriate. You could look in here though, different building types. You could pick from different options. I'm going to stick with office. Then you have operational schedule. This for an office, I'm going to assume it's going to have a 24/5 facility schedule as opposed to say 24/7, where you're going just all day, every day of the week. K through 12 has its own occupancy profile set, performing arts center, worship center. So for an office, I'm going to say I'll be operating 5 days a week. So I'm going to pick 12/5. And you get down here to the mechanical system type. This gets a more specific information now on your system. You can put in SEER values, different efficiency ratings, and define that. So this will let you define that system type that you selected a bit further. I'm going to stick with the central VAV system here. Outdoor air information. You could pick this. You could adjust the outdoor air per person, different ventilation rates if you so choose. And then as we scroll down here in a bit more, room and space data and export category rooms. You could also go on a space by space basis. So it just depends on how your model is defined. But in many cases, and this actually touches on a really important aspect of bringing in a Revit model into Insight for an energy analysis, you do want to make sure in your model that you have rooms defined. So I'll show you that here in a second. On the conceptual types for the thermal properties, you could go into this and you can edit just very high level, very basic definitions of different components of your building enclosure. At the level of development that we have exhibited here, I'm going to go with schematic types for my building, and I can come into here and I can actually have a much more descriptive selection of what I'm going to be importing into Insight for my thermal enclosure. So if I look at exterior walls, for instance, I could pick this, and I have selected a brick veneered wall system with plywood, studding, 6 inches of insulation, plasterboard. That's consistent with what I showed a few minutes ago within the model itself. I also selected the roof up here. I wanted to define an R20 roof over a roof deck. I could come down here to slab. This is a slab on grade with 10 inches of insulation along the perimeter. You could change that as well. Door types, you get the picture. You don't have to select all of these schematic level definitions. It will default to the conceptual types if you don't select something here. So you could also establish a shading factor for the exterior, which is a nice, quick global adjustment you can make, but I'm going to stick with what we have here. This last one here, you can indicate if you're using detailed elements or not. I think I'm satisfied with what we have at this point, so I'm going to select this, and our energy settings are now in place. We have a basic 5-story office building, occupancy schedule, the definitions of the thermal enclosure. We've established the variable air volume system type. And again, one other caveat here, I'm going to go to the floor plan. Let's say level 1. Let's just go into a floor plan really quickly. I'll zoom in here. I have a definition of different rooms. So you want to make sure you have your rooms established. You will not be able to do an energy analysis in Insight if you do not have rooms established. It's going to export a GBXML file that it's going to bring into Insight. You want to make sure that you have those definitions. That's sort of the backbone of how it exports an energy model for analysis. So I have gone through now and geolocated my project. We've defined the parameters. I've introduced these different menu options, but now we are ready to import this into Insight. So if you had done this previously, if you had exported the model and established an energy assessment prior, you can actually exist your previous analytical model. You can replace it with more accurate, more up-to-date information now. I'm going to consider doing this anew. So I'm going to say update energy analysis model, generate a new energy analytical model for the simulation, which can take some time. Okay, so we'll select that and process complete. The energy analytical model has been successfully created. So that's good. Now we wait. So it's pulling this into Carbon Insights, and it's going to take a few minutes here. I think it'll be quick enough that I'm just going to wait, and I believe this will generate, and I can show you live what we have. So here it is, generate Carbon Insights, view analysis. I'll select that, pulling up a browser window here, and it now is bringing us into Insight. I'll expand this window. You can see this information starting to generate live. What you see down here, this is our model having been imported now. So that is what Insight is understanding geometrically. You can see how it has made some default moves in terms of some of the subdivided thermal zones. And just have to wait a second for this to generate. But in the meantime, there's some features here with this graphic interface. You can measure certain components if you wish. You can take more of a perspective view into the project and look at it. That can sometimes be handy. You can also, it's an interesting little feature here where you can actually, let me sort of center my view a bit here. You can explode the model, start to look at some of the other elements. If you're unsure what's inside the model, how it imported it, if the interior walls, for instance, were conceptualized properly and brought into the model the right way, you can find that. And it's important to do that because there are times when Insight will actually not interpret your model completely the right way. That might be because of something that was not accurate in the modeling itself. Maybe you or your team didn't define some aspect of the model accurately. And so it is good to do a quick quality assurance test on that geometry. What you see now is information starting to be generated. It is running this analysis on the cloud, and it's going to give you a total carbon composite that's going to be comprised of embodied carbon and operational carbon. It has already run the embodied carbon piece, and you can see this is in kilograms of CO2 equivalent. And I can look here, this is 107,440.65 kilograms of CO2 equivalent. I do get this little caution sign though. Some of the materials are missing embodied carbon definitions. So there might be some parts of my model that I should go into and make sure that everything's fully defined. And if not, maybe I change some assembly types or material selections and try to get something that's going to fully import. for our purposes on this video, I am interested in getting this annual energy use intensity, this predicted EUI number, and trusting that that will generate here momentarily. While we're waiting for that, I will show you that within this embodied carbon piece, this bar chart you have here, you can start to get a breakdown of the different components of the model and the proportionality of the embodied carbon. So you can see here that the exterior openings, that's a high proportion. What I don't see listed here is the opaque wall assemblies. So that caution sign, that is the missing link here. So maybe in another video, I'll go and figure that piece out. But I do know that the entire building envelope had the thermal information on it. And so we have a complete sense of the operational carbon and our energy use intensity. So this was the point of this exercise, was to arrive to a predicted EUI number for a schematic level Revit model. And you can see here we have an EUI of 50.18 kilogram or kilobtus per square foot. And this is, you can see a breakdown of it portioned like this. This becomes really helpful when you're looking at your EUI number. This is on an annual basis, by the way, so it's kilobtus per square foot per year. And you can see that over the course of the year with this project in Boston, with the inputs that I have in here, it was a pretty well insulated, pretty well airtight building. Um, you can see the decimal points throw me off a little bit. You can see it's actually a fairly even distribution actually of heating, cooling, interior lighting, and equipment taking up the most of the four. But in short, I could scrutinize it from here. I could say, I'm looking at this. We're talking about Boston. It can get pretty cold. Maybe I'm a little suspicious of the heating. This is where maybe the smell test comes into play. I need to look at my inputs, look at my system types, look at the different parameters I indicated, and just make sure from a quality control, quality assurance standpoint that everything is in there properly. But in terms of workflow, in terms of how you assess your model, refine inputs, and import it into Insight, I trust and I hope that this quick video demystified that process and helps give you a starting point so you can start to do this yourself on your own projects. And uh, wish you all good things with your modeling endeavors. Thanks all.